Hi, welcome to Expertise Academy. This is Giri, lecturer in physics. In this video, we discuss about the Wattless current and power factor. So consider an AC circuit in which there is a phase angle of phi between root mean square voltage and the root mean square current. Consider AC circuit. AC circuit means alternating current source or alternating voltage sources connects with a RLC circuit. So RLC means resistor, inductor, capacitor. So here these three things are in connection series or individually. So consider AC circuit in which there is a phase angle. The phase represents the physical structure of the wave and position of wave is following or passing through the some axis. So phase angle of phi between root mean square voltage and root mean square current. The voltage is assumed to be leading the current by phi as shown in the phasor diagram. So phasor diagram shows the information about the directions of the different things, that means current, voltage and resistive or inductive resistance or capacitive resistance. So here we are showing shows the phase angle between root mean square voltage, root mean square current. So here root mean square current flows in x-axis. The root mean square voltage makes some phase angle with the root mean square current. Now root mean square current is resolved into two perpendicular components, namely IRMS cos phi along VRMS and IRMS sin phi perpendicular to VRMS. So the root mean square current is converts into two parts. IRMS cos phi along VRMS, IRMS sin phi perpendicular to VRMS. So look at this phasor diagram. IRMS cos phi is along with VRMS. IRMS sin phi is perpendicular with the VRMS. So let's verify these properties. The component of current IRMS cos phi, which is in phase with the voltage, is called active component. Which is in phase with the voltage is called active component. The power consumed by this current VRMS into IRMS cos phi, so that it is also known as wattful current. IRMS cos phi is the active current. The product of VRMS into IRMS cos phi is known as the wattful current. Next, the other component IRMS sin phi, which has a phase angle pi by 2 with the voltage, is called relative component or reactive component. The power consumed is zero, so that it is also known as wattless current. So here IRMS sin phi, this is the part of wattless current. The current in AC circuit is said to be wattless current if the power consumed by it is zero. This Wattless current happens in a purely inductive or capacitive circuit. So Wattless current is nothing but power consumed by that particular part is zero. Then it is called Wattless current. So this happens in a purely inductive or capacitive circuit. Next, power factor. Let's verify these power factors. The power factor of a circuit is defined in one of the following ways. Power factor is equal to cos phi, that is equal to cosine of angle of the leading or lagging. Another way, power factor is equal to impedance by resistance. Power factor is equal to Vi cos phi divided by Vi. So that means true power divided by apparent power. So these are the three things to define the power factor. Next, some examples for power factor. Power factor is equal to cos 0 degree, that is equal to 1 for a pure resistive circuit, because the phase angle phi between voltage and current is 0. Power factor is equal to cos plus or minus pi by 2, that is equal to 0 for a purely inductive or capacitive circuit, because the phase angle phi between voltage and current is pi by 2. Third example, the power factor lies between 0 and 1 for a circuit having RLC in varying proportions. So here cos 0 degree equal to 1 for pure resistive circuit, cos plus or minus equal to 0. Here, these are the examples to evolution of the power factors. Next, verify the advantages and disadvantages of AC over DC. Advantages. The generation of AC is cheaper than that of DC. So generation of AC circuits is very cheap when compared to DC. When AC is supplied at higher voltages, the transmission losses are small compared to DC transmission. Okay. AC can easily be converted into DC with the help of rectifiers. So rectifiers are used to convert AC current into DC current. Next, disadvantages. Alternating voltages cannot be used for certain applications, example charging of batteries, electroplating, electric traction. Next, at high voltages, it is more dangerous to work with AC than DC. In high voltages, AC not suitable to work for charging batteries, electroplating, electrotraction. AC voltage not suitable. So this is the disadvantages for AC compared to the DC. So thanks for watching this video. For more videos, visit www.expertiseracademy.com. Thank you.